Hello. In this lesson, we are going to be looking at how to look at angles beyond our acute, right, and obtuse angles and be able to graph them. We're also going to look at introducing another type of angle measure called radians, which we'll learn how to take degree measures, turn it into radians, and how to take radian measure and turn it into degrees. So at this point, all of you should be familiar with the three basic types of angles. An acute angle, which is an angle that is greater than 0 degrees, but less than 90. The right angle, which is equal to 90 degrees. And then the obtuse angle, which has to be greater than 90 degrees, but less than 180 degrees. 180 degrees, you might recall, is the measurement of a straight line. We call that the straight angle. So you might remember that one also. So when we get into trigonometry that applies to what we call the unit circle, then we look actually at a full circle of angles. And that gives us then 360 degrees for a full circle, and then we even will learn how to go beyond that. We'll also learn how to go in the negative direction. So some of the terminology that we're going to need to know is the parts of an angle, so that when we're talking about how to graph them and how to put them into what we call standard position, we understand the pieces and the parts. So one of the things that we look at is angles in standard position. Standard position means that the vertex of that angle is at the origin of an XY axis. The vertex of the angle is at the origin of an XY axis. That the initial side, where we say the angle's measure starts from, is on the positive portion of the x-axis. So the initial side is on the positive part of the x-axis. That's this part right here. And that's where the measurement always starts from in an angle measurement in standard position. The terminal side is what we refer to as the side of the angle where the angle stops its measurement. And that can be anywhere within the 4 quadrants or on an axis. Here it is shown in the 3rd quadrant as the terminal side. And then the measurement, and we'll talk more about this in a moment, but this is what we're looking at. This arc right here represents the measurement of the angle. And this symbol, you may or may not be familiar with this. This is the Greek letter theta. And we will use that a lot to represent just a general or unknown angle measurement. All right, so some other things that we need to understand terminology about our angles. We can now have a positive angle, which means it has a positive measurement, which is what you're familiar with. But when angles are in standard position, the measurement to get it to be positive has to be in the counterclockwise direction from that initial side, which is on the positive side of the x-axis. So if we want a positive angle measure, then we have to go counterclockwise in the opposite direction to the hands of a clock. And that then gives us a positive angle measure between the initial and terminal side. But we can also measure angles in what we refer to as a negative direction and get a negative angle measure. And that goes in the opposite direction, which is actually then the clockwise direction. So starting again at that initial side, I would then head down to get that negative angle measurement, stopping at the terminal side. All right, so one of the kind of special groups of angles that we often talk about is what we refer to as quadrantal angles. And they get their name quadrantal because the terminal side is on one of the axes, either the positive or the negative side of the axes, which means that they basically are one or more full quadrants of an angle. One or more full quadrants. So you might recall your quadrants. Everything is positive in quadrant 1, and then this is quadrant 2, this is quadrant 3, and this is quadrant 4. So quadrantal angles are one or more full quadrants, and that's where they get their name. So their terminal side is always on part of an axis. So 0 degrees is an angle measurement for us, but its initial side and its terminal side are both together on top of each other, creating a ray rather than an angle, a traditional angle where there's space between them. We have our 90-degree angle, which we know of course, is our right angle. And we can actually remember we were just talking about positive and negative angle measurements. So we can measure this in the positive direction. So we get a 90 degree as a quadrantal angle. We can also measure in the negative direction, and that actually gives us negative 270 because it's 3 90s, because every quadrant is 90 degrees for a total of 360 degrees in a full revolution, which is our degree measure of a circle, in case you didn't know that. So we have in the negative direction 1, 2, 3 quadrants, so that's negative 270 degrees. With our straight angle then, in the positive direction, we'd have 2 quadrants for a positive 180, and the negative direction we'd have 2 quadrants for a negative 180 degrees. Then the next quadrantal angle, its terminal side is down here. So in the positive direction, we get 3 quadrants, which would be positive 270. And in the negative direction, we have only 1 quadrant, so that's a negative 90 degrees. These, we'll talk more about this in just a moment, but these angles, 270 and negative 90, positive 90 and negative 270, positive and negative 180, these are what we call coterminal angles because they share the same terminal side. And then we have this final one. So notice that it looks a lot like the 0 degree as a ray, but now we're actually moving in the positive direction through all 4 quadrants. So that gives us then 360 degrees in the positive direction and all 4 quadrants in the negative direction. So that gives us a negative 360 degrees in the negative direction. All right, so we've just been talking about our positive and negative quadrantal angles. This is just summing it all up, showing you all of them, and actually pairing up what I was referring to as those coterminal angles. 0 and positive 360 and negative 360 are all coterminal. They have that same terminal side, the positive x-axis. So this is just a quick reference that pulls everything from the previous slide together into one picture. All right, so now we are going to make a sketch or drawing of each of these angles in standard position. So the nice thing about standard position is we always know where the angle is going to start. It's always going to start with its vertex at the origin and its starting or initial side on the positive x-axis. What takes a little bit of practice sometimes is being able to figure out where the terminal side is for an angle. So for example, 135 degrees. This is where understanding those quadrantal measurements is helpful. Because remember, this would be 0, up here would be 90, here would be 180, down here would be 270, and then we're back to the beginning with a full revolution of 360. So if our angle measure is 135 degrees, we know its terminal side is between 90 and 180. So it's somewhere in quadrant 2. We want to not just draw it anywhere in quadrant 2. We are expected to be sort of accurate here. So one of the things, remember, is that half of a quadrant would be 45 degrees. So consider that. And The other types of angles that we care about are like multiples of 30, and so we have like a 120. So if you divide this quadrant into 3 pieces, they're not all equal, by the way. So this would be like 90 plus 30, and this would be another 30. This would be 120. 120 plus 30 is 150, and 150 plus 180 or plus 30 is 180. And then this middle one would be half, so it's 90 plus 45, which actually is 135. And so what we gather from looking at how we divide this quadrant for the unit circle is that our terminal side will be right in the middle. So now I have my 2 sides. Now the last part, and this is a part that sometimes people forget, is the arc. So make sure you draw the arc. And the arc starts at the initial side, that positive x-axis, goes in the positive direction because our angle is positive, so up, which is counterclockwise, and stops at the terminal side. So that is our 135 degrees. With the second one, because it is in standard position, it still starts with its vertex at the origin, and it's starting our initial side on our positive x-axis. But now notice this angle is a negative angle measure. So for reference, I think of my negative quadrantal measures. Now I still have 0, but now negative moves clockwise, so it starts down. And this would then be negative 90, negative 180, negative 270, and when I get back to the beginning, I'm now at negative 360. So negative 150 would be between the negative 90 and the negative 180. So I know that its terminal side is somewhere here, which is our 3rd quadrant. So just like I divided the quadrant in that quadrant, the terminal side quadrant here, I'm going to do the same thing. So what I know is that splitting it in half, that's another 45 degrees. So that would be a negative 135. Splitting it into thirds, which would be right about there and right about there. So that my 3 pieces are here, here, and here. So each one of those is 30, because 30 plus 30 plus 30 is 90. This would be negative 120. And this one would be negative 150. And then another negative 30 would be my negative 180 to take me to the axis. So that means that my terminal side is right here at negative 150. So I'm going to draw that. And then again, don't forget, draw the arc. So the arc this time, because it's a negative measurement, has to be in the negative direction. It still has to start at the initial side. So the arc always starts at the positive x-axis. But now because we're negative, we head down in that negative clockwise direction and stop at the terminal side with an arrow. Don't forget the arrow. The arrow is important. That shows the direction of the measurement. So there's always an arrow pointing at the terminal side. All right, so now we're going to introduce our other main type of way to measure angles, which we refer to as radian measure. And I'm just going to give you just a quick bit of information about the difference between the 2 measurements. Our degree measures that we are familiar with up to this point are based on taking a circle and dividing it into 360 equal sectors. And the sector is like this little piece of pie or a little piece of pizza. All right. So if we create 360 of those going around our circle, each one of them is 1 degree, giving us a total of 360 degrees. So it's kind of a geometrically created measurement, and it doesn't work for all mathematical calculations. So radian measure is a measurement that's based off of the length of the arc that connects the terminal side and the initial side of the angle. So instead of measuring it as pieces of a pie, we measure it as how long is this piece of the circle, and we call that the radian angle measure. So that's where the radian angle measure comes from. All right, it is a part of the circle, or a piece of the circumference of the circle. You can look at it that way. Specifically when, and this is our unit circle, guys, specifically when the radius of the circle is 1 unit. So it's developed based on a radius of 1 unit, and then the length of the arc, which is part of the circumference, becomes our radian measure. Oops, stretch. All right, so what that tells us then is that because radian measure is part of the circumference of the circle, and our circle in this case has a radius of 1 unit, and we know circumference is 2 times pi times the radius of the circle, then we know that the circumference of this circle would be 2 times pi times 1, this radius, which just becomes 2 pi. What we can then extrapolate from that is that if this circumference is 2 pi in radians, but we already know that in degrees that's 360 degrees, then we can conclude that 360 degrees must be equal to 2 pi radians. Now this is why we care, because that actually creates an equivalency statement that we can turn into a conversion ratio. Because if we take a ratio of 2 pi radians over 360 degrees, that equals 1, because they're equivalent to each other. And then we can actually reduce that, because 2 is a factor of 360, so it becomes pi over 180 degrees. Then we can do the reciprocal of that also, and that's also equal to 1. And these then become the conversion ratios we use to go from degrees to radians or radians to degrees. And which one we use is based on what we want to get rid of and what we want to be left with. Just like we have done with other measurements, like inches and feet and seconds and hours. All of those, it works the same exact way. This is just summing that up for quick reference. So if we're starting with degrees and we want to be left with radians, we want to get rid of degrees and have radians, this becomes our ratio. If we're starting with radian measure and we want to have degrees instead, we want to get rid of the radians and be left with degrees. So that means that we would use this ratio, because this would cancel out the radians and leave us with the degrees in the numerator. So it's a quick reference is all. All right, so let's take a look at some of these problems. So we'll do some together, and then I'll give you a chance to try some on your own. So we're going to look at this first one of 135 degrees, and we're going to convert it to its radian measure. So 135 is an integer. So 135 degrees, like 135, is considered to have a denominator of 1. So again, I want to get rid of degrees, and I want to be left with my radians. So I need my degree measurement to be in the denominator. So I have 180 degrees, which is half of a circle, by the way, is equivalent to pi radians, which is half the circumference of our circle with a radius of 1. So what's going to happen here is our degrees will cancel, and we can reduce 135 and 180 a little bit. I can see a common factor of 5 in there. So division by 5 here is going to give us 36, I think. Doing this without a calculator this morning. Brushing up on my basics. Yep, 36. And division by 5 here is going to give me a 2 and a 7. So now, oh, I can see I'm not quite fully reduced because 27 and 36 are both multiples of 9. So I'm going to divide by 9, which will give me a 3 and a 4. So now what I have is 3/4 pi, or 3 pi over 4. So I've got 3 pi over 4 radians. And that would be my radian measure. So that's the basics. So why don't you guys try the 570 degrees, converting that one. All right, let's take a look at -30. The only difference is that we don't lose the negative sign. That's the only difference on a negative angle measure that you're converting. So if you have a negative degree, you're going to have negative radian answer also. So you're looking at -30 degrees over 1 times your pi radians over 180 degrees. Your degrees would cancel. And then they both end in 0, so that's your multiple of 10, or factor of 10, so that would go, and now you have 3 and 18. 3 is a factor of 18, so now you can reduce by 3. It gives you a -1 and a 6. So this becomes negative pi over 6 radians. So now we're going to look at starting now with this radian measure of 5 pi 6 and converting it into degrees. So I'm going to just start my work over here. So I have my 5 pi 6 radians. Now technically, okay, if you want to add in the units for your work, you'll see that there aren't normally, over here it doesn't write radians. Radians is kind of a placeholder unit. It's there, but we don't always write it, just so you are aware of why it's not written there. So we want to get rid of those radians, which means that we now need our pi radians in the denominator. And we want to be left with degrees, so we need our 180 degrees in our numerator. So now our radians cancel, and we have our degrees. We can also reduce the pi's, because there's a pi here and there's a pi here, so they would reduce to 1. And then we can look at reducing the 6 with the 180. And since 18 is a multiple of 6, then we can divide by 6. This gives us a 1. This gives us a 30 degrees. And so we have 5 times the 30, which would be 150 degrees. All right, so one of the things we have to start getting comfortable with is the equivalency between degrees and radians of our quadrantal angles. So if we're dealing with radian measure, we don't have to continually convert to degrees to understand what it's telling us. So these are your quadrantal angles in their radian measure. So these are equivalent to your 0, your 360, and your negative 360 degrees. This is equivalent to your 90. This is equivalent to your negative 270. The pi is equivalent to your positive 180, and the negative pi is your negative 180. The 3 pi over 2 is your positive 270, and the negative pi over 2 is your negative 90. That's how they equate to one another. Now we're going to look at graphing angles that are in radian measure. Right now I can understand you might need to or feel more comfortable converting to degree measure first so that you make sure that you fully understand. I'm not going to do that. I'm going to show you how to graph directly in radian measure using our quadrantals. All right, so here we're going to graph pi thirds radian. So notice it's not there, so I'm adding this in. I understand it's radians because there's no degree symbol. Be aware it has nothing to do with the pi. It has to do with the fact that I don't have that little circle, that open circle for a degree measure that tells me it's radian measure. So here, what I'm looking at, if I want to graph pi thirds, I'm going to think of this as 1/3 of pi, because pi is half my circle. It's over here. It's going into the two quadrants. And so I'm looking at, okay, so this is 1/3 of this half of the circle. So what I'm going to do, and I actually divide it into 6 equal pieces because that just helps my visualization. So I'm going to take each quadrant and divide it into thirds, just like we did with the degree measures. So this is a 30, that's a 30. This is a 30, that's not really a 30. This right about there is probably a 30 and a 30. Boy, those are not good straight lines. Let's try that again. There we go. So this is 1/6 of pi, 2/6 of pi, 3/6 of pi, 4/6 of pi, 5/6 of pi, and then 6/6 would be pi. So which one of those fractions is 1/3 equivalent to? It's equivalent to 2/6. So that means here's my terminal side. My initial side, of course, is still on that positive x-axis, always. And I'm measuring in the positive direction. So from my initial side, I arc up to my terminal side. All right, so now I want to graph this -5 pi/4 radians. And again, I know this is a radian angle because there's no degree symbol on it. Again, it has nothing to do with the pi. Our unit circle angles and radians have pi in them, but we have a lot of other angle measurements other than unit circle angles that have no pi in them. So we want to be careful about making that assumption or thinking they are one and the same. So I have a negative angle measurement. So now I'm going to look at going in my negative direction. This has a denominator of 4. So what I'm going to do, remember this is 0, and this would be negative pi over here. So this is half my circle in the negative direction, which is 2 quadrants. Because my denominator is 4, I'm going to divide that half circle into fourths. So I'm going to cut each of them in half. So I have 4 pieces. Like so. All right. So this would be -1/4 pi, -2/4 pi, -3/4 pi, -4/4 would bring me to -1. And that's not quite enough because I have -5/4 pi. So I'm going to keep going. I'll divide this one in half and that one in half too, just to complete it. But this would be -4/4, so here's my -5/4 pi. If you want to keep going, this would be -6/4 pi, -7/4 pi, and then this would be -8/4 pi, which is -2 pi, all the way around. So this tells me my -5 pi/4 matches this one, so here's my terminal side. My initial side, of course, is back over here on that positive x-axis. Now I want to be careful that I draw my arc in the negative direction from that starting initial side. So here's my initial side. Negative means I start down and arc to my terminal side, like so. All right, that finishes up all of the examples for this particular assignment or lesson.